We are going to look at an example of an unbalanced Wye load where the load has the same power factor but different values of resistance. This Y connected load is connected to a supply voltage of 208 volts. In phase A to N, there is an 8 ohm resistor at a power factor of 0.866. Phase B to N is a 20 ohm resistor at a power factor of 0.866. Phase C to N is a 25 ohm resistor at a power factor of 0.866. 3 different resistors, all at the same power factor. What we want to find for this question is the current in each phase. Then draw a phasor diagram showing the phase voltages and the phase currents, where they are all at. And in the end, we want to find the neutral current. Hit pause here and find the phase currents in each phase and the power factor angle for each phase. So we have continued on with the question now. We have found the phase voltage. If the supply is 208 volts, that is the same as the line voltage. Whenever we say supply, or whenever we say supply, we mean line voltage. So the phase voltage would be 208 volts divided by root 3 to give us 120 volts. If we have 120 volts in each phase, we can find the current in each phase. Phase current A to N equals the voltage on the phase over the resistance of the phase, so 120 volts over 8 ohms is 15 amps. Phase current B to N is the phase voltage on phase B over the resistance of phase B, 120 volts divided by 20 ohms gives us 6 amps. Phase C to N is 120 volts divided by 25 ohms, or 4.8 amps. And then we found the power factor angle as well. If the power factor is 0.866, the power factor angle will be inverse cos on your calculator of 0.866, which is 30 degrees. Here, and draw a phasor diagram that shows all the phase voltages and the phase currents for this load. This is what our phasor diagram should look like. Voltage for phase A to N is always at 0 degrees, 120 volts. Voltage B to N at 120 volts is at 240 degrees. Voltage C to N of 120 volts is at 120 degrees. The phase voltages are 120 degrees apart. Once we know where the phase voltages are at, we can put the phase or line currents, they're really the same thing, in place. Phase current IAN or IA lags phase voltage by 30 degrees. So 30 degrees behind VAN is phase current IA, which is 15 amps. 30 degrees behind phase voltage B to N is phase current B, which is 6 amps. Phase voltage C to N is at 120 degrees, and 30 degrees behind that voltage is the phase current IC is 4.8 amps. Now we are just left with the neutral current. Pause here and draw a horizontal vertical chart to break the phase currents into the horizontal values and vertical values to give us the neutral current of the system. Alright, the last part of the question, we need to do this horizontal vertical chart where we break each phase current into its horizontal component and vertical component. And for each current, all we do is take the phase current times cosine of the angle and phase current times sine of the angle to find the horizontal and vertical parts of that current. And we do that with each of the 3 currents to find which part of the current is horizontal, which part of the current is vertical. So this IB to N of 6 amps has a horizontal component and a vertical component that make up that current. We break each of these currents into their horizontal and vertical values. These should be the values that you get here. Once you have these values, we simply total up the horizontal values and total up the vertical values to find a total horizontal value for our neutral current and a total vertical value for our neutral current. Keeping in mind that all negative values add together and positive values are subtracted from a negative value, they go the opposite direction, whether we're talking about horizontal or vertical component. We take a total horizontal, subtract the total, we take a total positive horizontal, subtract the total negative horizontal to get our values. Once we have that, we simply draw a triangle where the horizontal side is our total of 7.79 horizontal. Our vertical side is a total of minus 5.7. And when we know these two sides, we can use Pythagoras' theorem to find the neutral current. And that current comes out to 9.65 amps. Hopefully this helped you with the parts of this question that you need to understand to be able to figure it out. That's it.